Also, we're going to kind of like look at how we can do it a little bit more quickly, especially on this one here. I want us to at least like set it up first, sort of without using the calculator, but because of how extensive it gets, if you're not using the calculator, we're going to use the calculator here. So, I think, oh shoot, I don't have the filled-in version of this. Whenever we looked at, flipping back to example 1, you had a graph that looked like this, and whenever we were doing the rectangles underneath the curve, they looked like this here, but much better because I had drawn them with the rectangle tool. And notice for this graph, our right corner of our rectangles was on the graph, right? So we would call this a right Riemann sum. So if your right corners of your rectangles touch the graph, then that's a right Riemann sum. The second part that we did, oh, it was example 2. I redid this. I could change it back. It's the third thing we've done, but I did number it. Right. The second part that we did, we used rectangles that were above the curve. So that looks like that. Like this. And for this problem, the left-hand corner of your rectangle is touching the graph, right? So this one was a left Riemann sum. So that the left and the right Riemann sums are not always above or below the graph. Sometimes the right Riemann sum may be above the graph, and sometimes it may be below. Same with the left. Sometimes it's above the graph, sometimes it's below. Depending on your graph, it could be some of both, depending on what you're looking at. So a right-hand Riemann sum and a left-hand Riemann sum are not necessarily always your overestimate and your underestimate, but it's that you have a left endpoint on the graph or a right endpoint on the graph. So whenever example 2 asks us to estimate the area between the curve and y equals x minus 1 to the third plus 2, and the x-axis on the interval from 1 to 3, sound off of my phone. Whenever we're looking at this, we're supposed to use 8 sub-intervals. If we're doing a right Riemann sum, it means the right-hand corner of our rectangle is on the graph. So first of all, on that graph, it only tells us to look between 1 and 3 on our graph. So if we highlight the section that we would be looking for here, we're looking for this area right here. And this is not going to be the easiest to draw in, but we're going to try anyway. So if I'm taking this section from 1 over to 3, and I have to split it into 8 pieces because it tells me to use 8 sub-intervals, what is the width of each little interval going to be? 0.25, right? Or 1/4. Because if we cut this into 8 pieces here, it would be going up by 0.25, right? So if we're doing a right Riemann sum, it means that we want to have the right corner of our graph on our rectangle, or right corner of our rectangle on our graph. So this first one I'm going to draw is going to be like not all that helpful because it looks pretty flat right there. But you'll see as I go along, we would have this one, and we'll have this one. This one. Here. Here. I know they're so small it may be hard to draw in by hand. Mine are starting to overlap here. I think this last one's way up here. I think I didn't make that one right. Let me try that one right there again. I think that was right there. Okay, so all of those little rectangles right there would be the ones that we need to find the area. Right? And the right end point is on the actual graph for all of these here. Now, is this one going to be an overestimate or an underestimate? This one's going to be an overestimate, right? Notice that the right Riemann sum over here was an underestimate. So we'll talk about later why it is sometimes an overestimate and sometimes an underestimate. But right now we really just want to think about finding the values of these here. So I could do these all separately, and it would take forever, especially without a calculator. But if I think about what's happening, what's the width of all of these little rectangles going to be? Each one. 0.25, right? So each one has a width of 0.25. So for every single rectangle, I'm going to be doing 0.25 times the height of that rectangle. Just put random rectangles there. So I have 0.25 times the height of this first rectangle. The height of that first rectangle can be given by f of our x value right there, right? So, because if I plug in, it looks like it's about 2, but I don't think it is actually 2. So, let me pull up Desmos here. Yes, Riemann was the name of the mathematician that came up with the methods for it. So, if I take my equation, I'm going to call it f of x instead of y, and if I plug it in, so if I am doing this, I didn't make it. The next one. I think it was on another one. Okay. If I find f of f of 0.25 is not correct. What is my x value right here? 1.25, right? So f of 1.25, I get 2.015625, right? So I could write that down for each one of these. This is going to become extensive where we really don't want to do this. So I could do f, I'm just going to do f of 1.25 right here. Sorry, I don't know why it's putting these random rectangles in the graph. Okay? That would give me the area of this rectangle, right? And so I could do 0.25 times f of 1.25. And I get I'm going to write this one down, but I'm not going to do it for all of them. It'll take forever. 5039 and so on, right? So I could go through, and I could find all of these, and then I could add them together, right? But what I'm going to see is I'm going to have the next one is going to be 0.25 times. What's the height of the next rectangle going to be? F of 1.5, right? Because right there, if I plugged in 1.5, it would give me the coordinate on that, the y coordinate on that graph, which would be the height of this rectangle. So I'm going to have f of 1.5. And then the next one would be f of 1.75. And then the next one would be f of 2. And then this is going to keep going all the way until I get to the last one here, which would be f of 3. Now, if I want to type this into the calculator, I could shortcut it a little bit, right? So, in the calculator, since every single one of these is multiplied by 0.25, I could factor that 0.25 out front. So, I could just write it like this, 0.25 times f of 1.25 plus f of 1.5 plus f of 1.75. I think it will be acceptable for us to put plus dot dot dot, and then our last one is going to be f of 3. But when I actually type that in to the calculator, it will look like this. Something to notice about this here, when you are doing a Riemann sum, if you are doing a right Riemann sum with 8 subintervals, then you need to have 8 numbers right here, because it's going to be 0.25 times 8 different numbers. You should not have 9 numbers. If you were doing a right Riemann sum, then when you're looking at that interval, you do not use 1 for that. So from 1 to 3, you don't use 1 because your right endpoint is on the graph, so you're not using that left endpoint of the graph. All these other points are your right endpoints. So we don't use 1, but then we use 1.25, 1.5, 1.75, 2, 2.25, and so on. And you can see we've got 1, 2, 3, 4, 5, 6, 7, 8. You should have the same number as you have intervals there. And if it doesn't match it, especially what kids do a lot of times, they have 1 too many. They use all the way from 1 to 3. Then you need to go back and change something about what you've got. So for this one, we should get 9.0625 will be our answer for that. So that would be our estimated area. Questions on that? Okay, for the next one, we've got the same equation, same graph, but this time we're still looking at the same area. So I'm going to highlight that same area again. This is what we're looking at. Same 8 subintervals that we're looking at, but this time our right corner is where we're going to have our corner of our graph. I'm sorry, yes, left corner.
And do we stop at the 1 instead of going all the way down?
Yes, because it tells you in the problem, it's just from 1 to 3. It tells you 1 is less than or equal to x less than or equal to 3. If they had told us otherwise, we would have.
We don't go like on the y, like we don't go all the way down to 0 on the y.
Oh, no, you do. I just don't have mine scrolled down enough there. Yes, you're right. Sorry about that. I didn't even realize I wasn't scrolled down. All right, let's try that again. Okay, let's retry here. And I'm going to draw in these here with my left endpoint here on the graph.
Where are you like starting your left? Like where are you starting?
I want it, so like right here, so each one of my subintervals is going to be, it's really hard to tell in those first ones because it's so flat, but what I'm doing is I've got each one of these subintervals, so I know I want to have a rectangle between all of those little tick marks right there. So you want your right corner of the graph, so like I'm going to go on the, left corner of the graph to be on the graph. So at 1, I'm going to go up and I want that left corner. It's a little easier to see once I get over here. Like if I go up, I want this corner right there to be on the graph. So from 2, I would go up till I hit the graph, and then I would draw that rectangle. And then at 2.25, I'll go up till I hit the graph. It's a little easier to see once there's a little more elevation in the graph. Then at this point, I go up till I hit the graph.
So you're waiting till you hit like one of the like darker lines.
The red line is what I'm looking for. So like I'm going, so like for this last rectangle, I'm starting on that left side and I'm going up until I hit that red line.
Okay.
And that's how tall my rectangle needs to be.
Oh, okay.
For that.
So it doesn't matter. It can be anywhere as long as it's on the red line. Like
It's got to be on that red line.
Yeah.
Yeah.
It has to be on like 6.5 or anything like that.
Right. Right. I can't tell for sure exactly where it is at. Based on this, to find the exact value, I could plug my x coordinate in, and that'd give me the exact value there. But we'll use the calculator because it will take so long to do otherwise that it's not worth it. So if we look at this, then this is going to be very similar to what we just did, right? What's the difference in what we just did and what we're doing here?
We're going to start at 1 and go to 2.75.
We start at 1 and we go to 2.75 because those corners of our graph are right here. I'm going to use red. Right here, right here, right here, right here. We're looking at the left corners this time. And that last left corner that you have is right here at 1.75. So you kind of think whenever you split, when you go from 1 to 3 and split it into 8 subintervals, there's 9 numbers there. You got 1, 1.25, 1.5, 1.75, 2, 2.25, 2.5, 2.75, 3. That is 9 numbers. We're using the left ones, so we leave off that last one whenever we're doing left Riemann sum. If we're doing the right Riemann sum, we leave off the first one and use all the right side for that. So what we're doing is we're doing 0.25 times, we'll have f of 1 plus f of 1.25 plus f of 1.5 plus, I'm going to do a dot, 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 and that will go all the way to 2.75 for this. We'll type that into the calculator. So since we already had that in Desmos, what I can do is I can go over here and just put f of 1 right here, add that one in, and I can take this last one off because we don't need the f of 3, and that will give me my answer for that. So I got 7.0625. And that would be an underestimate for this. So you've got an overestimate and underestimate for these. Now, are there any questions on this first?
I just have a question about the format.
Yeah.
Can you just do f of 1 plus ... or do you need to do like
I would it's a good idea. You definitely have to have at least that 1.25. Because if you just go f of 1 plus ... f of 2.75, I don't know how many increments you're using there. I don't know what you're going up by. So you definitely have to have the 0.25. It's a good idea to put 3. That way I know it's going in like a linear sort of fashion for that. There. And so when you're doing your homework, I'm going to let you use the calculator just because these can take so long without them. Particularly if it's a more complicated equation. But I would at least like for you to write this stuff down for me and then write down what I have right here is like your bare minimum for that. The assignment that you guys are going to do is come from the textbook. Oh, but where is it? We go to Canvas. I don't have it on here. Oops, I got too many things open. There we go. All right. Let's see.
Thank you, TB. This week?
All right. It's going to be $2.99. And let me flip over here.
Ethan, what's your opinion?
I'm just doing like the height of that.
Yours?
Yeah, like where I don't know, wherever like big.
And you're going to do 25 to 35 odd and 32.
Ethan's gonna
Yeah. That's what you're doing too, right? Oh, you're the packer. I think I'm just like
yeah, you're